Hello everybody, welcome to the section arrays. So in this section we are going to use different ways to make an array using NumPy and Python. So let's dive in, let's see how it looks like. So before diving coding itself, I just want to make some reminders before coding. So in the arrays we have a one dimension, we have a two dimensions, and we have a three dimensions, as you see over here. So mostly in this course we are going to use the one dimensions and two dimensions only. So right now, as you see, that is the one dimensions. I have a one row, and two dimensions it may be more than two rows. So let's dive to the coding and let's see how it looks like with the NumPy library. So right now we are going to start importing the NumPy library, and usually we use the syntax import. So right now I have my import and I'm importing my NumPy library. So if I run it, my library is ready to be used. But usually we use the short ways, like in shortcuts, so I can import my NumPy as NP. So NP stands for just a small shortcut for my NumPy libraries. So if I run it, that is going to be assigned now. And if you want to make sure that NumPy was imported, what you can do is you can just type it in NP and make a dot, and you will see all functions that belongs to my NumPy. Okay, perfect. So my NumPy is ready to go. Now, before using those functions which is in a NumPy, let me just create one of the lists, because I want to use my object which is list, and we will convert that as array. So I will say that let me just create my new that is my new my list, and that is going to be list 1 2 3. So right now you see I have my list. It has only 3 integers and it was assigned to my list. If I run it, perfect, that is going works now. So what I can do is I want to convert that list to the one dimension array. So what I can do that, so I will say from the NumPy library I will recall the array, and I will say that I want to use the my list. You see, so I'm just converting my list, which is that one 1 2 3, to the array. So if I run it, perfect. So right now I have my one dimension array, and I can save it to the array 1. And later on, if I want to recall that array 1, let me just recall it array 1, and it is going to post me one array. But in the second scenario, that imagine that I have a list in the list. So let me call it my matrix. So I can say that that is my list, and inside that list I have another list as well. You see, so let me just say that is 1 2 3. Here I have on the second list I have 4 5 6, and here we have 7 8 9. Perfect. So right now what I did, I just create a list, and inside that list I have a small 3 list as well, and all of them was assigned to my matrix. So if I recall my matrix, it is going to publish all my list here. But what I want to do is I want to use this object and convert to the array using the NumPy library, and let's see how it looks like. So from my, let me just put it a little bit up. From my library on NumPy, I want to use the array function, and I will provide my matrix. So let's see how it looks like. Perfect. So let's just analyze. Let's see what is going on over here. I will get my pen. So it indicates that that is array. And right now I have my 2 brackets. So I have a 1 and I have a second one. So that tells me I have a 2-dimension arrays now. Do you remember that in the beginning we had only 1 dimension? Where it is? Here it is. So it says that I have an array and I have a 1 bracket here. That is a 1 dimension, which is my vector. And now we have a 2 brackets here. So it is indicating me I have a 2 dimensions array. So what we did so far is we used our object, which is list, and we just generated our arrays. But the NumPy also has built-in functions that is going to generate the numbers without using the list. So let me just go ahead and show them. So right now, let me just zoom out a little bit using the NumPy, and I will say the arrange. So that is one of the functions. Now, these arrange functions will ask me, I need to give my start point and then my finish point. So I will say that, hey, can you start from the 0 all the way to the 10? And it's the same that we use the range function for the for loop. So my first digit is included and the second one is not included. So if I run it, it is going to generate me array, like in one dimension array. So you see that is starting from the 0 all the way to the 10, which is not included here. So you see that 9. But if you want to make sure that it is included, what we can do is I can say that instead of 10, I will put 11. And right now I see one dimension array starting from the 0 all the way to the 10. And also I can insert my another argument. So right now, if I say that, hey, I will make it 2, so that's 2, it stands for that it is going to skip every second number. So imagine that I want to have an array which is starting from the 0 and I want to print only even numbers. So if I run it, it is going to be printing me 1, 2, 4, 6, 8, and 10. Basically, it's not printing me the even numbers because it's not calculating if the 4 or 2 or number 6 is even number. It's just skipping those numbers. So instead of 2, if I put a 3 over here, so that means, you see, so right now it starts from the 0, it will skip 3 numbers and it will display the another one. So I have a 0, 3, 6, and 9. If you put some big numbers, like imagine that I have a 100, let me put 101, that I want to get included 100 as well, and I will say that, hey, can you just go with a 9 step? So make it a 0, and after that skip 9 points, print the second one, skip 9 points, and print it. So right now, as you see, it is going to print all numbers using the arrange functions, which is built in NumPy. So let me just go ahead and show you some different functions which is in the NumPy. Let me just zoom out a little bit. So right now, one of the functions that is arranged, and it generates me different numbers, one dimension. So there is another one that says that from the NumPy library, there is the function zeros that is going to generate the zeros. So I will say that, oops, let me just put it, if I provide number 4, what is going to do is, so I have a one dimension array with the 4 zeros in. So that if I change that number to the 6, that is going to generate 6 different numbers with one array. So what if I want to make a 2-dimension array? So using the same one, what I can say that from the NumPy zeros, and I need to provide my tuple. So you see right now inside that my function, I'm providing my tuple, and let me call it 4 by 4. Oops, let me just make it 4 by 4. So if I run it, it is going to generate me two-dimension array, and I have all zeros inside. So the first one is representing my rows, and the second one representing the columns. So let me change it. Imagine that I have a 2 by 4. What does it mean? That I have a 2 rows only, and I have a 4 columns. So if I run it, it is going to generate me that way. And also in the NumPy, we have the similar one with the zeros. I have NumPy ones. So that is going to generate an array. It may be 1 dimension or 2 dimension with the ones instead of 0. So if I provide a 5 over here, what does it mean? That if I do not provide a tuple, like only one single digit over here, that is going to make me generate a 1-dimension array with ones. But what if I want to make it 2-dimension? What I need to say that NP ones and provide inside another tuple. You see? So let me just say that that is a 3 by 3. So that is going to generate me 2 dimensions, a 2-dimension array, which is 3 by 3. Do not forget that the first one is representing my rows, and the second one represents my columns. So if I say that I want to make 5 by 10, oops, by 10, let me just zoom out a little bit, and if I run it, perfect. So right now I have 5 different rows and 10 columns. So the another function in the NumPy library that I want to mention about, it's a Linspace. So it's almost similar with the arrange that we used before, and I will explain what's the difference between them. So let me just go ahead and I will say that from the NumPy library I want to call Linspace. That is the second one. So right now I need to specify three different arguments: the start point, the last point, and how many points, even points, I need to see in between. Let me just go ahead before doing that Linspace, reminded what we did so far in arrange. Imagine that you see it says a start from the 0 all the way to the 101, which is not included, and the steps are 9. That means print the first one, make a 9 step, a second one, make another step, and display that one. But the difference in the Linspace is I need to specify my first one. Let me just say that start from the 0 all the way to the 10, and I will say that between that, or let me just select the small one, let me just say it's a 3, start from the 0 all the way to the 3. So imagine that you have a number line and we have a 0 which just goes 1 2 3. So in that range I want to make a 10 different points, and the distance between each point is going to be same. So I will specify that is going to be 10. So if I run it, let's see how it looks like. So right now you see I have a one-dimension array, but how we can understand that I have only one brackets here, even if, guys, you see I have 2 lines now. So it is going to print me, let me just put a little bit up so you can see clearly what is going on now. You see I have my NP, like a NumPy Linspace, starting from the 0 all the way to the 3 and divided by the 10. Actually, it's not divided by 10. So on my number line between 0 and 3, I have a 10 points, and the distance between each point is going to be same. So if I just do something different, I will say Linspace and from 1 and all the way to the 4, and I will say that, hey, can you make 100 points? If I run it, perfect. So you see how we can understand, is it one dimension or two dimension? First of all, I need to look how many brackets I have. You see, I have 1 brackets. It started from the 1 all the way to the 4, and I have 100 different numbers, which is in between that range.